Have you ever just looked up at the moon and wondered, seriously, where did that thing come from? Well, its origin story is one of the greatest detective cases in our solar system. We're talking a cataclysmic impact, a mysterious culprit, and brand new clues that are finally cracking the case wide open. So let's dive into this cosmic mystery and uncover the truth that's been hidden right under our feet.
See, to really get the moon's birth story, you first have to understand how its mother, a long-lost planet, died. This isn't just about creation. It's a story of planetary destruction and sacrifice on a scale that is it's almost impossible to imagine.
All right, so chapter 1 of our story is the leading theory for how we got our moon. It's called the giant impact hypothesis. And trust me, it's as dramatic and violent as it sounds. And it fundamentally shaped the world we live on today.
Okay, I want you to picture this. It's about 4.5 billion years ago. Our early Earth, what we call a proto-Earth, is just minding its own business when, bam, it gets slammed by another planet. And this wasn't some little fender bender. This was a head-on collision with a world roughly the size of Mars, a body that scientists have named Theia.
And the fallout from this was, it was absolutely staggering. It totally reshaped our planet, changing its size, even its orbit. Theia, the planet that hit us, was completely obliterated, just gone. The debris from this cosmic crash got thrown into orbit around Earth, and eventually it all clumped together to form our moon. But here's the crucial part. Theia didn't just vanish. Its fingerprints, its very essence, became a fundamental ingredient in both the Earth and the moon that we know today.
So, we've got a crime scene, right? We have a timeline, and we know what happened. But for decades, the identity of our main suspect, Theia, has been a complete mystery. Who was this planetary culprit, and where in the universe did it come from? And this one simple question, who was Theia, has sent scientists down two completely different paths, each pointing to a totally different origin story for the moon's mother.
So, was Theia an outsider? A planet that formed way out in the cold, outer reaches of the solar system, made of icy, carbon-rich stuff? Or was it a local, a neighbor, born and raised right here in the hot inner solar system, built from the same rocky, metallic material as Earth? This is really the heart of our whole detective story.
Now, to solve a mystery this old, you can't just go back in time, so scientists had to become cosmic forensic investigators. They did the next best thing. They started looking for fingerprints left behind in the ancient rocks of both the Earth and the Moon.
I absolutely love this analogy from the research because it just perfectly captures this idea of reverse engineering the past. By tasting the final cake, analyzing Earth and the Moon, scientists can actually figure out the ingredients that went into it, including that one mysterious ingredient we call Theia.
And the key to this whole investigation is something called an isotope. The simple way I think about it is they're like different flavors of the same element, and the ratios, how many of each you find, act like a fingerprint, or even better, like a chemical zip code that tells you exactly where in the solar system a rock or a planet first formed.
So to build their case, researchers from the Max Planck Institute and the University of Chicago gathered a whole range of evidence. They took a look at rocks from deep within Earth's mantle, they analyzed those precious lunar samples brought back by the Apollo astronauts, and they used meteorites as sort of a cosmic reference library for different parts of the solar system.
Okay, so this is the crucial point. They decided to focus on iron. Now, why iron? Well, because a huge chunk of the iron in Earth's mantle today was probably delivered by Theia during that giant impact. So if they could analyze the isotopic fingerprint of iron in our rocks, they could basically analyze the fingerprint of Theia itself.
And after all this incredible forensic work, analyzing these ancient rocks and tracing these cosmic fingerprints, the evidence led to a really stunning conclusion. The case was finally cracked. The first major finding, published in the journal Science, was definitive. Theia was not an outsider. Her isotopic fingerprint matched that of a non-carbonaceous body. That means she was a local, born right here in the inner solar system. She was, for all intents and purposes, Earth's long-lost sibling.
But they didn't stop there. The analysis got even deeper. By calculating just how much stuff Theia contributed, the scientists could pinpoint her home address even more precisely. She didn't just grow up in the same neighborhood. She grew up on a hotter block, even closer to the sun than Earth did.
So this gives us a much clearer profile of our mystery planet. Theia was Earth's sister, rocky and forged in the hot inner part of our solar system. And this also probably means she was much drier, with way less water and other volatile elements. This doesn't just identify her, it actually starts to change our entire map of how planets were built.
But you know how it is with any great detective story. Solving one mystery only uncovers another one, and this one might be even bigger. This discovery about Theia's origin has created a fascinating new puzzle about the very building blocks of our solar system.
So here's the new problem. The specific isotopic fingerprint of this innermost solar system material, Theia's building blocks, it doesn't match any known meteorite we've ever found. So if this stuff existed, where did it all go?
Well, this leads to what they're calling the missing reservoir theory. And the idea is pretty simple. This unique material formed super close to the sun. The reason we don't have any samples of it lying around as meteorites is because it was all gobbled up by the inner planets while they were forming. Mercury, Venus, and Earth essentially ate all the evidence, creating this missing reservoir that we just can't study directly.
And this is where it gets incredibly exciting for the future. This theory implies that the final clues to our solar system's origin story, those pristine samples of this missing material, might be just sitting there, waiting for us on the surface of Venus or Mercury. So future missions to these planets aren't just about exploring other worlds, they're about finding the missing puzzle pieces of our own.
So we've identified the moon's mother as Earth's hotter, long-lost sister. But this whole discovery just reminds us that our solar system is kind of like a big family with a really long and complicated history. It just makes you wonder, right? What other family secrets, what other long-lost siblings and missing pieces are still out there, just waiting for us to discover them?